Okay, so I'm recording. We're now recording this. This is our second session. This is class 2, and we are going to be looking at this problem. And after I finish looking at this problem and how to solve it, I'll just talk a little bit about how we're going on with the course, and then after that, I'll do some more material.
What?
We will be, let me just pin myself. Give me a second so I can. Okay, I am now pinned. So you will only see me while you are doing this. I hesitate to mute everybody. I would like everybody to mute themselves. And as soon as you have something that you'd like to say, of course, wait until I finish a sentence, but unmute yourself and ask your question. Okay, so our question that we're dealing with is 3 minus 3x is less than 15, and we want to solve it, put the answer on the number line, and also write it in interval notation. This is a review of what we had done on Thursday. So just like in an equation, the first thing we're going to do is isolate our x. If at all possible, you would like to leave the x on the left side and the numbers on the right side. So I'm taking away the 3 by subtracting 3 from both sides, and I'm going to be left with negative 3x is less than 15 minus 3, which is 12. And of course, I want to get what x is, so I'm going to divide by the coefficient of x, which is negative 3. Now, this is something we're going to have to be very careful about. When we are dividing or possibly multiplying by a negative number, which is what we're doing now, we're dividing by negative 3, what happens to our inequality is that it gets switched. The sense or the direction of the inequality changes. Here it was less than, so it switches to greater than. This becomes x greater than 12 divided by negative 3 is negative 4. And this is my solution written as an inequality. And as a number line, what we have to do, here's my number line, here's my 0, here's negative 1, negative 2, 3, negative 4. That's going to the left. To the right, it would be positive 1, 2, 3, 4. So here's a number line. Since this says x is greater than negative 4, it means we have to start at negative 4. And we have to make that an open circle rather than a filled-in circle because it does not include the negative 4. It's greater than negative 4, but not greater than or equal to. And then since this arrow is pointing to the right, the inequality, we draw the arrow going to the right. So we get the number line looking like this, an arrow starting at negative 4 and going to the right. In terms of interval, that was the number line. In terms of interval notation, remember we always start our intervals on the left side and work our way to the right. So the start of this interval on the left is negative 4. It's going on and on without any stop, so it's going on to what we call infinity. And then we have to enclose it in our parentheses. So first of all, at negative 4, since it's an open circle, we put a regular parentheses. Remember, we put a bracket if this would have been a filled-in circle. At the end of the interval, at infinity, infinity always gets a parentheses. So here is my result in interval notation. So we have both the number line, the inequality, and the interval notation. Does anybody have a question about how to do that type of thing?
I have a question.
Yeah, sure.
Yeah, so when you usually do like go back to like where the first step is, when you usually do it, aren't you supposed to add because there's an subtraction right there?
But remember, you always look, here's what are we trying to get rid of? We're trying to get rid of this 3. Now this 3, I don't look at the sign that's after it, I look at the sign that's previous to it. Now when there's no sign, it's really understood as if there's a +3. That's why I have to subtract 3. I don't ever look at what's following the number, I look what's preceding the number. Does that make sense to you?
Yeah, it makes sense.
Okay, any other questions? Okay, so if that's the case, then I'd like to go on to new material. So this is where we left off. We know how to solve inequality. We solved equations on Thursdays. We solved inequalities on Thursday. I'm now looking at my example sheets. We are going to be doing all the types of questions that are on the practice example sheet, the types that we haven't covered yet, and that will cover, this is basically chapter 1 in our textbook. So let's go through those. So the next type of question I want to look at is something that looks like this. This is what's called a compound inequality. What a compound inequality means is that you really have 2 inequalities written together. It looks a little strange. You're not used to seeing 2 inequalities on the same thing. This is really a shorthand for saying -4 is less than 2x plus 4. And also 2x plus 4 is less than or equal to 10. In other words, we have this inequality from here to here, and then we have this inequality from here to here. And instead of having to write the 2x plus 4 twice, we just write it once. And we could separately answer both of these inequalities, but there's a much quicker way of doing this by solving it both at the same time. So let's see a quick way of solving this compound inequality. So here's our problem. What we're looking for is to isolate the x in the middle. What we want to do is be left with just plain x in the middle, one number on the left side, one number on the right side. And whatever we're going to do with this, we're always going to focus on the middle. Focusing that what we want to do is get this to be a plain x. Well, if this is 2x plus 4, of course, the first thing we want to do is get rid of this 4. So I have to subtract 4. What does that mean I'm subtracting 4? I'm subtracting 4 from the middle, so therefore I have to subtract it from both ends. I have to subtract 4 from the left, And also from the right, because I'm really doing two problems at the same time. It's not enough just to subtract it from one end or the other end. I have to do, I'm really saving myself by trying to do two things at once. Okay, so if I do -4 minus 4, that gives me -8. This stays less than 2x, because the 4 has canceled out. And this stays less than or equal to 10 minus 4, which is 6. So I've gotten what's in the middle here simpler. I don't have that 4, but I still have a 2x, and I want to get just a plain x. So what I'm going to do is I'm going to divide this by 2. But remember, whatever I do in the middle, I have to do the same thing at both ends. So that what ends up happening is I get -8 divided by 2, which is -4. This is less than x, which is less than or equal to 6 divided by 2, which is 3. And I'm going to go up here on the top and rewrite this over here. So we get as a final answer -4 less than x less than or equal to 3. And the question is, what does this mean, and how do we give our answer? Here the answer is in terms of an inequality, but can we give our answer on the number line, number 1, and in interval notation, number 2 as well? So what we have to understand is what this double inequality means. We're stating two things. We're stating that -4 is less than x. And at the same time, and so I'm using this word and, at this exact same time, I need the x to be less than or equal to 3. So how is that? What does that mean? To say that, and this is something you should understand also, we don't like to write the number first and the letter second. We usually start our inequalities starting at the x. So what does it mean that -4 is less than x? That's equivalent to saying that x is greater than, is greater, I have to put the open side by the x because that's what it is, than -4. In other words, on my number line, it's going to look like this. Here's the 0, -1, 2, 3, 4. Here's my -4. And this is going to be an open circle with an arrow going to the right. The second thing says x is less than or equal to 3. So I'm going to put that on the same exact number line. I'm going to go to the 3, which is right here, and put a filled-in circle at 3 because it says less than or equal to. And now my arrow is going to be going to the left. Now, since this is an and situation, for something to be an and situation, it has to be both at the same time. In other words, what we're looking for is where do these two inequalities, these two number lines overlap. And they overlap in the section starting from -4 and going to 3. So if I really want to write, this is really what the number line is going to look like. It means to start at -4 and go until 3 with an open circle at -4 and a filled-in circle at 3. We don't need the stuff that's to the left of -4 because it's not overlapped. We don't need the stuff that's to the right of 3 because that's no overlap. The only thing that where both of them occur is in this section from -4 to 3. And if you look at it, it really looks, if you look at the inequality was x is less than or equal to 3 and greater than -4, this inequality. On the number line, if you leave out the x part, you just put in the -4 and you put in the 3 and you connect the two pieces, you have the number line. You have the example written on the number line. And on top of that, in interval notation, it would look like this. Here's my interval. Where's my left end of the interval? It's at -4. Where is the right end of my interval? It ends at 3. This is not going until infinity. It's starting at -4, that's on the left. It's going till 3 on the right. Notice at the -4, we'd have to put a parentheses because the -4 is not included. But at the 3, we have to put a bracket because the 3 is included. And if you look at this, this, and this, they sort of all look the same. This and this almost look the same except that you leave out the x. And that's the point of this compound inequality. Does anybody want to ask me a question? Any questions? Okay, so then I'm going to give you one to try. You know what? Actually, I'm not going to give you, when we go into breakout rooms, I'll give you one to try. If there are no questions about this, then you're going to have, I'm going to give you the examples. Remember, I'm going to give you the examples that are on this practice sheet 1. I am now going to be erasing this and going on to another type of problem. Again, remember, anytime you want, you can stop me and say, please do it again, or review, etc. We're now going to be talking about something called absolute value equation. First of all, let's just remind ourselves what it means when we say, what is the absolute value of something? So if you see something like this, a number with 2 straight lines on either side of it, that is read the absolute value of 3. And what we mean by the absolute value of 3 is, what is the value without its sign? We just want the number, we don't want its sign. And obviously the absolute value of 3 is just equal to 3. Whereas the absolute value, let's say, of -7, its value, without looking at the sign, but just the value of the number, is 7. So basically, to find the absolute value of a number, all you're going to be doing is dropping its sign. What do we use the absolute value for? Well, if we're on a number line, where is 3? 3 is to the right here. The absolute value of 3 means how many steps do I have to take if I'm starting at the origin, at the 0, and I want to get to 3. Well, obviously the number of steps I'm taking, the number of spaces is 1, 2, 3. Therefore, the absolute value of 3 is 3. When it comes to -7, here's -7 all the way over here. And 1, 2, 3, 4, 5, 6, 7, right? If I'm asking you what is the absolute value of -7, I'm asking you how many steps, how many spaces is it from the origin to -7? So if I count the steps, it's 1, 2, 3, 4, 5, 6, 7. In other words, it's 7. What is the difference then in terms of the -7 that has a negative and the +3 that's positive? The only difference is not how far it is from the origin, but in which direction. In other words, the point of a negative sign or a positive sign is to tell you which way do you go. But if you don't care which way you're going, you just want to know how far to go, that's what the absolute value is about. So you know about absolute value from before. What I'm going to show you is what happens to an example where you have an equation and it has an absolute value in it. So I'm going to take a very simple equation, and from that very simple equation, I'm going to then go to something that's a little bit more difficult. Suppose I give you an equation like this. The absolute value of x is equal to 5. And I'm going to show you a geometric way to look at it, in other words, on the number line, and an algebraic way of looking at it, in other words, just in terms of the number. Remember, what I'm telling you is I don't know what x is. I just know that when I take the absolute value of x, my answer is going to be 5. So if I look at my number line and I ask myself, where could the x be located? Remember, to say that the absolute value of x is 5 means that we're 5 steps, 5 units from the origin. Well, I could go 2 ways. I can go to the right, 5 steps, 1, 2, 3, 4, 5, and get to +5. Or I could go to the left 5 steps and get to -5. Both of these numbers, the -5 and the 5, are 5 units away from the origin, and therefore the absolute value is equal to 5. So it turns out that there are 2 answers to this. There's either x equal to 5 or x equal to -5. This actually makes sense algebraically, or in terms of the numbers as well. Think about it. What could this number be so that when I drop its sign, I'm going to get a 5? It could have just been a plain 5 to start out with. That would have certainly given me 5. But it could also have been a -5, because if I take the absolute value of -5, that means drop the sign, my answer is going to be 5. So it turns out when you have an equation with an absolute value in it, you actually are going to usually, I would say in 99% of the cases, end up with 2 solutions. One from using the positive number and one from using the negative number. Again, your final answer, you can either just write it as x equals 5 and x equals -5, or if you wanted to write it just as, here are your answers, 5 and -5. In other words, you don't have to go to the number line and show it on the number line, because it's not an inequality. I was just trying to indicate why my answer is what it is. What you should be aware of is that if I would have given you something like this, the absolute value of x equals -3, I know what you tend to think is, oh, I'm going to make 2 equations. I'm going to call it x equals -3 and x equals 3. But actually that would be wrong. Why? Because the absolute value of a number always has to be a positive number. It never can have a negative. So if I say the absolute value of x is equal to -3, this is a faulty equation. It can't have any solution. So therefore, this is my solution. I don't have to do any work at all. That being the case, let's see how we would solve absolute value equations that are a bit on the more difficult side. Does anybody have a question before I go on? Okay, so I'm erasing this and I'm going to a slightly more difficult example, and then I'll do one that's even more difficult than that. Suppose I were to give you this example. The absolute value of 2x minus 6 plus 2 equals 10. Okay. Obviously, this is much more complex than just the absolute value of x equals something. But the method we're going to be using will work the same. Just like in any equation, you want to isolate things. In this case, what you want to first isolate is the absolute value. You must get an equation that just says absolute value equals something. So what's bothering me here is this fact that there's a 2 on the outside of the absolute value. So the first thing I'm going to do is I'm going to subtract 2 from both sides. Notice I don't worry what's inside the absolute value. I'm talking about what's outside the absolute value. So this gives me 2x minus 6 in the absolute value equals 10 minus 2, which is 8. I have now gotten my absolute value all by itself. Once I do that, the next step is to write 2 separate equations. Actually, I stop for a second before I start writing my 2 equations. I make sure that this number, the absolute value, is equal to a positive number. Because if this would have been the absolute value of something equal negative, it would have been an impossible situation and I would have had no solution. But this is okay. Here are my 2 equations I get out of this one equation. One equation is going to be the 2x minus 6 equal to 8. In other words, I just brought these absolute value signs, write it as if there's nothing, there was no this absolute value sign at all. But that is not the only solution. To get our other solution, I'm going to have to put the 2x minus 6, which again is what's inside the absolute value, equal to the opposite sign of this, equal to negative 8. Because if this 2x minus 6 would have been positive 8, this whole thing would have worked out to be positive 8, the absolute value of positive 8 would have been 8. And if this whole thing would have worked out to be negative 8, and then I did the absolute value of negative 8, I'd also get 8. So here are my 2 equations, one with a positive number, one with a negative number. I have to solve each of these equations. Once you've solved the first one, the second one is going to be almost a repeat of the first one. Here, I'm going to add 6 to both sides. And this will give me 2x equals 14. And then to finish this up, I divide by 2, and my answer is x equals 7. So one answer to this problem is x equals 7. Don't stop here. You have to get the other answer as well. I'm going to do the same thing on this one. Again, I'm going to add 6 to both sides. This will now give me 2x equal, well, negative 8 plus 6 is negative 2. And when I divide by 2, my answer here comes out to be negative 1. In other words, my 2 solutions are negative 1 and positive 7. If you write only one of those solutions, well, you're half wrong. You've not totally solved the question. That's if you have what's called an open-ended question where you're just asked what is the answer. If you're giving this on a multiple choice and you pick the answer that just says, let's say 7 and not -1 and 7, you're going to get it totally wrong. It doesn't make a difference which you write first or which you write second. I could have just as easily written 7 and -1. I just put the -1 first because it comes first on the number line, but it doesn't make a difference. And you don't even have to put it in these fancy braces if you don't want to. You could just leave your answer like this as well. Or you could just write it with a 7 and -1. That would have worked as well. All that would have worked. Okay? Does anybody have any other questions?
Professor.
Yes.
I haven't joined the first session from last week,
Okay.
and I'm a little late for this session as well. Did you have an attendance?
Did I take attendance? Yeah, I took attendance already.
Oh, okay.
Okay, so after class, or when we go into breakout rooms,
Yeah.
stay out. Don't go into the breakout room until you see me, so then I can
Okay.
keep the attendance. Okay.
All right.
I'm going before I do anything more. Now I'm teaching, but when I go, I'm going to tell you a little bit more about how to handle this, et cetera, et cetera. Let's continue with our work here, and then we'll talk at general or more specific things that have to do with the general class in general and marks and attendance, et cetera, a little bit later. Okay, I want to give you another example to try. Question is, where did I write that example? I had a specific example. Too many papers. All right, let me make one up. I thought I had one written down, but I can't seem to find it. Well, oh, I do have it. I have to remember where you wrote things down. Okay, here's a question for us to work on together. I'm going to start you off with the first steps, and then I'm going to let you continue and see if you come up with the right solution. Let's say I gave you something that looks like this. It's -3, and then there's the absolute value sign, and inside the absolute value is 3 minus 2x, and the plus 5, and that equals -19. Obviously, it's a lot more complex than the first one we did, but if you sort of think about this absolute value sign almost like a parentheses, then really it's the difference between a very simple equation and one that's a little bit more complex. The first thing, and this is what I'm going to start you off with, is to make sure you isolate your absolute value. That means what you want to do is make sure that all you have on the left side of your equation is this absolute value. There can be things inside it, but outside of it, there should be nothing. So how do we do that? So let me put this on the side so that I can work on it. So if I look at this thing, as with any equation, think of this as just a plain x. The first thing you want to do is get rid of anything that's either added or subtracted. And I see a plus 5, so the first thing I'm going to do is I'm going to subtract 5 from both sides. So this will give me -3 absolute value 3 minus 2x equals, well, -19 and -5 gives me -24. And the next thing I see is there is a number in front of the absolute value. This is like having a -3 in front of an x. When you're solving an equation, you don't want to get -3x, you want to get what x is. So the next thing is to divide by whatever the absolute value is being multiplied by, so that you end up with the absolute value of 3 minus 2x equals -4 divided by -3, which is +8. Now I have a regular absolute value equation. The absolute value expression is isolated. It equals a positive number, so I know I can continue this. Let's now solve this. I'm going to give you a couple minutes to solve this. By the way, if anybody came in after I took attendance, please put on the chat that you're here so that I can change the attendance. I think that's the easiest way to do it. Just send me a chat. Okay, Daryl, I see you're here. Okay, I think we had enough time. Let's see if we could finish this example. We've done a lot of the hard work already. Now we're at the point where we have to split our equation into two pieces. We're going to write one equation being 3 minus 2x equals 8. And the other equation, we're going to write 3 minus 2x equals -8. In other words, we take this thing that's in the absolute value sign, drop those two signs, and write it equal to this number for one equation and equaling the negative of this number for our second equation. And we solve each of these equations. Now, first I have to subtract 3 from both sides over here. So this gives me -2x equals 5, and divide by -2. So my first answer over here becomes -5/2. That's one answer. What about over here? Let's see what this gives me. Subtracting 3 from both sides to get the, again, it's very similar work. We get now a negative 2x equals, well, negative 8 and negative 3 is negative 11. And I divide by negative 2 on both sides again. And notice I have a negative divided by negative, so that becomes positive. So my answer becomes 11 over 2 as my second answer. And you don't have to change your answer to decimals or anything, though if you did, it wouldn't be wrong. But this is, we usually leave our answers as fractions if they come out to be fractions, making sure to reduce the fractions if they can be reduced, but these can't be reduced, so this is it. So we get our two answers, negative 5/2 and positive 11 over 2. And that's how we solve these absolute value equations. Does anybody have a question before I go on to the next part? Okay, so now I'm going to erase this and we're going to go on to the last type of questions that were on our practice example sheet 1. Numbers questions 16 through 19. And somebody had asked me a question, sent me an email about it, but we hadn't covered that. So let's talk about covering those examples. One of the points of solving an equation is that we can use that to solve what we call real life situations. We can use an equation to answer a question that is something that has a story attached to it. It's something that we sometimes call word problems, or we call them verbal problems, things that are explained in words, but that if we could set up an equation that explains the situation, then we can solve an equation and get an answer to an actual word problem. Now, if I look at number 16, it says the length of a rectangle is 2 more than the width, and the perimeter is 80. Find the dimensions of a rectangle. As we go through the course, there are going to be various different times where I will introduce these word problems, and I'll give you a method of solving those particular word problems. I won't give you all the word problems at the same time. I think it becomes overwhelming. One of the hard things is translating from words to math. So we're going to do each type as it comes along. So this is what's called a perimeter problem. And specifically, we're talking about the perimeter of a rectangle. Okay, what is a rectangle? I think everybody knows what a rectangle looks like. Our whole world is sort of filled up with rectangles. Just look at the things on that you have hold your names. Those are rectangles. The building blocks, not everything is built out of rectangles, but the basic building blocks that are used to construct houses, to whatever, is this type of figure that's called a rectangle. In a rectangle, we have 4 sides. The 2 pairs of opposite sides are equal, and the angles that we have are all what we call 90-degree or right angles. We have these square corners. If all 4 sides are the same, it's a special type of rectangle called a square. The perimeter means what is the total amount of all the sides added up. If I'm talking about a real life situation, if I'm talking about the perimeter of my backyard, which might be a rectangle, I'm talking about how much fencing would I have to use to enclose the whole backyard? How much will it be to go all the way around? That's what perimeter is about. A little later in the course, we'll talk about the area, which means if you'd want to put flooring on the bottom of in your room, that would be something that would involve area. Today, we're just talking about perimeter. And the basic formula for the perimeter of the rectangle is P equals 2L plus 2W. L stands for the length. This is one length. The opposite side is also the same, so that's also L. And the smaller sides we usually call the width. This would be one width, and this would be equal because the two opposite sides are always equal. So if you would add up all four of these things, you would get 2 L's and 2 W's. So if you wanted a formula for what the perimeter is, it's P equals 2L plus 2W. Let's see what this says. In this particular example, we're told that the length is 2 more than the width. Now, I guess let's call the width W. So there's a W here and W here. And we're told the length, the L, is 2 more than the width. So let's remember the words more, less, times, etc. When we say 2 more than something, what we're doing is we're taking 2 and we're adding it to what we started out with. To say that the length is 2 more than the width is telling me that L is W plus 2. 2 more, add 2 to your W. If it would have said 2 less, then instead of adding the 2, I would be subtracting the 2. Now, when it comes to addition, it wouldn't have made a difference if you would have said this is W plus 2 or 2 plus W. It doesn't make a difference because when you're adding, the order in which you add doesn't affect your final answer. But if I say 2 less, don't ever say 2 minus W. 2 less means the 2 is the number that's being subtracted. So therefore, that would have had to be W minus 2. Okay. But in this case, they told me that the length is 2 more than the width. So the L is W plus 2. That means this is also W plus 2 because this is equal to the length. And if I look at all 4 sides, and let's just use the W parts because this is the important thing. My 4 sides are W, W plus 4, W, and W plus 2. To find the perimeter, I have to add all the sides. I have to do W plus W plus 2 plus W plus W plus 2. That's my total perimeter. Or I could have done 2 times W and 2 times W plus 2. It's the same thing. Notice when I add all of these up, W, 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 and W like terms is 4W. And 2 plus 2 is 4. So in terms of W, my perimeter is 4W plus 4. And they actually told me that the perimeter is equal to 80. So this means 4W plus 4 equals 80. And now I have a simple equation to solve. I get the 4 to the other side. This gives me 4W equals 76. And if I divide by 4 to get the W alone, I get W equals 76 divided by 4, which is 19. So that means the W, or the width, is equal to 19. And the length, which is W plus 2, means it's equal to 19 plus 2, which is 21. So when it asks what are the dimensions of the rectangle, the word dimensions means both the length and the width. So I could write width equals 19, length equals 21. Or sometimes they do something like this. 19, the little x, that means by 21. The dimensions are 19 by 21, which means one side is 19 and one side is 21. So you could write the dimensions this way, or you could write it this way. Either way, we've solved this problem. Any questions about this? Okay, so let's do another type of example. Let me see. I'm going to erase this and give you a similar example for you to work out on your own. And then I'm going to explain a couple of things, and then I'm going to break you up into breakout rooms so you can start finishing the work that I'm going to be giving you. Okay, so I'm looking at, let's look at number 19 on the sheet. On the sheet, it's told the length of a rectangular poster, the length, let's just write that, I don't care what it is. It's a rectangular poster is 8 inches less than the width. And the perimeter of the poster is 64. And they want you to find the width of the poster. That's question number 19. I'm going to give you a couple minutes to try that. And then we'll do it together.
Professor?
Yeah, sure.
Is there is that worksheet on concept, like, is it on Blackboard concept?
Yeah, it's on, it's on the weekly, I think I put it on the weekly, there's something called weekly. It's either on the weekly examples, or it's on the information page.
Okay.
Let me see if I can, if I look at my, it's definitely, it was posted before last Thursday. There will be a new one posted for the next session as well. It is, okay, just do this problem, then we'll discuss how really how you're supposed to approach this class.
Okay.
Now that we're in class number 2. But please, let's work on this question.
Okay.
Excuse me, Professor. That says 8 less width.
The length is 8 less than the width. I guess I should write it more clearly.
Oh, okay.
It's on your sheet, that's why I didn't write it down. Here it was. 8 less than width. That clearer?
Yeah, thank you.
Okay, I think we can start working on this together now. Right, just like we did before, we're going to draw a picture. You don't have to draw the picture, but I always find when it comes to geometric type things, like triangles and rectangles and squares, I like to look at a picture. I found it makes it clearer to me. Now we're told that the length is 8 less than the width. Again, let's call the width W. And the length we're calling L. And what they're telling us is that the length is 8 less than the width. In other words, the L is W minus 8. Remember when it says 8 less than, here's where English and math don't always coincide. We have to put the 8 at the end. 8 less means the 8 is being subtracted. Don't write 8 minus W. That would mean W less than 8. When it says 8 less, the 8 is at the end subtracted. If it says 8 more, then you're adding 8 to it. Okay, so if I add all 4 of these sides up, I'm going to get W plus W minus 8 plus W minus 8. That's my perimeter. Is going to be equal to 64. Now combining the like terms, W, and W gives me 4W. Negative 8 gives me minus 16 equals 64. Add 16 to both sides.
Get your own shit.
Mute yourself. So I get 4W equals 64 plus 16, which is 80. And if I divide by 4, I get
What are you looking for?
W equals 20. And that's all they asked me to find. They didn't say find the dimensions. They just said find the width. The width is equal to 20.
He did that already.
Any questions about this problem? Okay. So let me just talk to you for a minute. How do we proceed from here? We have now finished chapter 1. If you got the book, or if you're getting the book, I'm not going to check if you have the book or not. And I mostly am going to be giving you homework on Delta Math, or by sending you sheets. The book is certainly helpful. If you want something to refer to, a guide as to what this course is about, the textbook is a great source of all the things. Our whole course is built around the textbook. So then when I say we finished chapter 1, I mean chapter 1 in our textbook. We will cover over the semester 9 chapters. So we have covered, as I said, we finished the first chapter. We did it rather quickly because it's, I assume most of this material, except for maybe the absolute value equations, is something that you've seen before.
Wait, Professor.
Yes.
For the first class session we had, was the homework 3-step linear equations?
Okay, so let me tell you what the homework was. There were 2 homeworks that I asked you to do. One homework was this practice sheet. I told you to do, make sure to finish examples 1 through 9.
Okay.
For homework for Thursday, our homework is to finish this. In other words, to finish 10 through 19.
Okay.
In addition, I have given you homework on Delta Math. On each session, when I assign, like if you look at homework number 1, you will see it's not just one example or one section.
It's 3.
There are about 10 sections that I ask you to do.
Oh.
And there is a due date. And the due date, I think the first due date is on Thursday, the 3rd.
September 3.
Right. Now,
Okay.
there's going to be, there's one additional set of examples that I gave starting today, which is on absolute value equations. I hadn't given you any examples on absolute value equations yet, so that will also be due on the September 3rd. That's Thursday.
Okay.
So homework 1 and homework 2 on Delta Math is due for Thursday. How am I going to make up your mark? Your marks are going to be made up by a number of things. Obviously, major is the final exam. The final exam is worth 60% of your final grade.
Yeah.
The rest of your mark, the other 40%, comes from a combination of homeworks done and
Quizzes.
there's going to be a midterm, and then there's going to be homework and quizzes.
Oh.
Now the homework basically that I'm asking you, I'm checking on Delta Math. All I'm checking for your homework mark is it done? I don't care if it's 100% or 50% as your final grade. What you need for the homework mark is to have done the homework. If you did them wrong, if you did 5 examples and you got all 5 of them wrong, I will see that you did 5 examples. That's what I required you to do. So therefore, you will get, even if you got 0 as a score, you are getting your complete homework mark. In addition to that, I will assign certain examples on Delta Math to be like a quiz. which will give you only one time. You'll be able to do the example only one time. They're not going to be here now. What usually you get, if you don't get it right, you can do it a second time. Here it's going to be you do it once. That is, some of your quizzes are going to be just on Delta Math. And I will
Okay.
tell you, mostly it'll be probably outside of class. I probably will give you a time limit. I won't start that until next week in any case. There are also going to be quizzes that are going to be, I'm going to give them on Blackboard. I'm going to tell you go to Blackboard and you're going to be assigned a specific amount of time to do it. Some of them will be multiple choice examples. Some of them will be what we call open-ended questions. Again, how that, I will give you plenty of notice before a test or a quiz is coming up.
Okay.
At this point, everybody, what you're supposed to be doing is getting onto Delta Math, getting an account, and doing the examples. You'll see that I gave an account. Now, in order to do that, what you have to do is go to the information on Blackboard. In the information section on your Blackboard account, you will see not only the Zoom number, you will see our Delta Math account number. And if you haven't signed up for Delta Math, a lot of people, most of the people, I'd say more than half the class, probably close to 3/4 of the class, has already signed up. If you
Yeah.
haven't, make it a point to go to Delta Math. Go to your Blackboard account and check in information for all the information that you need. Does anybody have a question before I put you in breakout rooms?
The 10 through 19 questions, that's on Delta Math, you mean? Like we complete those on Delta Math?
I'm sorry. No, the 10 through 19 is on this sheet that we've been working on in class. In other
Oh,
words,
okay.
okay, so there are two homeworks. This practice sheet does not have to be handed in. I'm
Got
not
it. Okay, that's what I was confused about. Okay.
we will go over anything that you have a question about. I think I already sent you the answer key, so you'll have the answer key. If you don't know how to do a problem, because basically these sheets, these practice example sheets are from, I called from the department, and they're going to be what our midterm and final are going to consist of. So therefore, this is very important for you to be able to do. Any other questions? Okay. Partana, did that answer your question about finding the homework? Okay. Again, anytime you, first of all, let me just tell you that, so as I said, 10% of your mark is doing homework, just doing the homework. Not whether you're doing it right, just doing it. 60% of your mark is the final exam. Another 10% is your midterm. So it leaves you 20% that's going to be these quizzes and tests that are going to be given during the term. I will tell you what is a test and what is going to be considered a mark on a test as it comes along. Very important to, if you miss a class, to look at the recording. I actually put a separate section on your Blackboard account that's called recordings. So you'll hear, and I will give you record class 1, class 2, class 3 with a date. So you will know if you missed a class, you can always see what we learned by going through the recording.
Oh, okay. Yeah.
Does anybody have a question before I put you into breakout rooms? What I want you to do in the breakout rooms is start to work on these examples 10 through 19 on this sheet. You should always have reference to the practice example sheet that we're going to be doing. Each class, I will tell you, like for next class, there's going to be practice example sheet 2. You will have to bring that to class. It's not a lot. Have it handy, whether you have it on your computer or whether you have it. I like to print it out so that I have it handy. So those will include the examples that we will be doing in class. Okay, I'm now going to put you in the breakout rooms. I'm going to again put you in, let's say, 5 breakout rooms, so they will have 6 people in each room. Try to get to know somebody, see if you can work on the problems together, get started on the homework. I'll come around to each of the breakout rooms to talk to you as an individual. If you have any questions, that might be an easier way to get in touch with me. Again, I do sign on around 9 o'clock, both Tuesday and Thursday. So if you want to get on early and talk to me personally, then that's fine also. Okay, so I'm stopping the recording now, and I'm going to